Well, hello guys. Welcome to another tutorial of Khan's CAD Academy. Today we will be discussing something about animation and simulation. Particularly we will be discussing Geneva mechanism, and through Geneva mechanism we will discuss how to open Solidworks files and then making the assembly. We will study some mates, and then finally we will do the animation of the Geneva mechanism. So now we will start this thing. We'll first open the files. Yeah, I got these files. If you don't have these files, you can ask them in the comments below, and I will send these files. I will send these files to you. So that's not a problem. First we will open these files. This is the base of the Geneva mechanism. Now I open the second file. Okay, this is the other portion of the Geneva mechanism. Now the third one. So in order to learn this animation of Geneva mechanism, you must have these three parts. If you don't have these parts, you cannot do this. So must first make sure that you have these files. Okay, so I start with this one. This is the base of the Geneva mechanism. Now at this point I will try to make assembly from this file, and we'll go to the file menu and we'll click on the make assembly from part. When I click on it, it goes into the assembly graphical interface. I will click. Now it wants me to select which one to import first, so I will select this too. It's the base. Keep in mind, those parts which you do not want to get into the motion, you must select them as the base or the first object, else they will not be animated. If you select the base part on the second or third position, so they will interfere the animation and they will not animate. So it's an advice to choose the part which is not included in the animation. So choose it as the base part. Okay, now we'll try to import the other files. We'll go to insert components here. I'll import another file. Now I got this file open, and now I will insert another component, this one. Okay, now we'll go into the mate options. Mate, you click on the mate button here, a menu opens, and here we'll go to the mechanical mates. In mechanical, we'll use the hinge mate today. Hinge mate basically helps in rotation motion, and it's very simple to apply. First we will it wants us to select the concentric sections. So I will select this one and this one. Okay, now it asks for the edges, so I will select this edge and then I will select this edge. So you can see it has aligned itself, but it has aligned itself improperly. We'll go down in this menu and we'll change this alignment, and now you can see that alignment has changed. Now you press the OK button and you can see that it has been aligned perfectly and it's free to rotate here. Okay, now we have the other part. We will apply another hinge mate again. Click on the hinge mate. It is also again asking us for the concentric sections. I'll click on this one. Then I have already made a hole here, and I'll click on this one. Now it's asking for the coincident sections. Click on this one and then this one. Now it's aligned, but it's again misaligned. I will press this button and we can see that it has aligned itself. So up till now we studied about how to import the file and then how to apply the mates. You can see we can simply rotate these, but as we haven't applied the motion analysis, so they are not detecting each other. We'll apply that later when we do the SolidWorks motion. Now if you want to animate this, we'll go to the motion study here. Okay, now the first thing that we must do is to apply the contact. Now what it says, that we cannot apply contact in the basic motion. Yeah, it says right, we must first choose the motion analysis. Now to turn on the motion analysis, we must go to the SolidWorks add-in. Now here we have the SolidWorks motion. We will click on it, and when we click on it, we get motion analysis. And motion analysis, we can generate a contact. When there is a contact, we can see a relative motion between two objects. So now I will click on the contact. Okay, now it's asking me to select the objects which I want to have contact like. So I will select this one and this object. Now whenever these objects will come in contact, they will not interfere each other. They will basically be separated from each other. They will not interfere each other. Now I click on it. So as you can see, it has simulated a contact. Now I increase this timeline to have a motion time increased. Now how to get the Geneva mechanism start running? So we need to apply a motor. Okay, we apply a motor at this point, and when we go to the menu, it's asking for the RPM. So I will simply put it 10. Okay, there's nothing to change. I'll apply it. Now dear friends, keep in mind that as I go to the setting menu, it's asking for frame per second. Now what does this frame per second mean? The more the frame per second, the more the accurate animation becomes. If we are going to animate something on a very lower frame rate, so it will not give us good results. It will either interfere or either the motion will be disrupted. So it's better to have a decent frame rate of about 100. So it will give us a good animation, a pleasant animation basically. So we press OK. Now we will simulate this mechanism by pressing this button which says calculate this motion steady. When I press this button, it will start its calculation and it will start moving. It will also turn on the motor. One part will rotate, and now as we applied contact, so due to this contact, whenever the one part come in interference with the other part, they will rotate relatively. So I will press on the calculate button. Now let's see what's happening. Look, it's adjusting itself. We have to wait for a while. Now look, it has come to its place. Now from this point and onwards, this animation will be regularized and there will be no interference. There will be a smooth animation. So we have to wait for a while when it's going to complete. Now at this point we will see when they come in contact, other part will move relatively. This was the thing which we wanted to simulate. It will be as accurate as it is in real time. Now other thing, as we increase the frame rate, the motion analysis time is also increased. So if you want to have, but the accuracy is also increased. Now as we can see, the motion analysis is done, and but it's for a very less time. So we can also increase this time to 16 seconds, so we can get 2 or at least 3 rotations. We'll again calculate the steady. We'll again wait for this. Initially, as they are at a haphazard position, they will try to balance as the motion is calculated. Yeah, now it's the time that the motion is calculated. Like the contact is basically established here, and further on we will not see any irregularity in it. So we have to wait. When it simulates, it will be a perfect animation. Sorry for the sipping sounds as I am having the tea. We'll wait for this animation. Now we see at the second time it's coming in contact and it will be as smooth. So guys, the analysis has been done. Now we'll press the play button. Now we'll see the perfect animation. Look at it. It's really going smooth. So that's the thing we wanted. Now, if we want to remove this thing which was in the start, so first we must do we must orient this thing. We must orient this little. Okay, when we orient this, so this irregularity will also be removed. We can do it by having a temporary mate here. We go to mates. Yeah, we'll go to mate and select this one. Now this is basically tangent to the spine. As I move, okay, let me check it out again. It's not doing well. We'll go to the mates hinge. We edit it. Sorry. Mate. Now we go to alignment. Yes, we have changed this now. It's okay. Okay, now we can see it is perfectly aligned with it. But it's a temporary alignment. Okay. Now as we have set up this thing to initial position, we'll go to here and we will remove these two mates because we just wanted them to locate the position. As you deleted them, now we'll again run the simulation. This time we will decrease the number of frames to 50, I guess, so it will be simulation will take a little bit less time. I'm going to adjust this menu a little bit. Okay, now we'll start again, run the motion analysis. Okay, now the motion will start from this point. As it has started, now we can see that there is no difficulty in the motion, and the motion is at a very perfect. It's very perfect now. Yeah, it is going to be perfect. It's good now. Now as this simulation ends, we will save this video. We have to wait for this. Now guys, we play this animation and it's look perfect. That's it. So guys, thank you for joining us today. I hope you learned something from this, and please don't forget to subscribe. Don't forget to subscribe, and please, if you want these parts, do comment in the comments box, and I will send you these files. So thank you very much, guys, for joining us today. Take care. Bye bye.